Example 5. F of x is e to the x divided by the natural log of x plus 4. And they ask us to find the slope of the tangent at x equals 4. So we're going to have to find f prime of x and then evaluate it at 4. Well, we've got a numerator of e to the x and a numerator prime e to the x, because the derivative of e to the x is e to the x. We have a denominator of the natural log of x plus 4. So the derivative of our denominator is 1 over x plus 4 times 1, chain rule. So that's just 1 over x plus 4. So a symbol, always start with the denominator, end with the denominator squared. So denominator, natural log, derivative of the numerator, e to the x, minus the second function, that's denominator, derivative of the numerator, minus the numerator, which is e to the x, derivative of the denominator, which is 1 over x plus 4. And all of that is over the natural log of x plus 4, but the whole thing is squared. And you can use parentheses instead of those heavy brackets as well. Now, I want to get rid of this complex fraction. Notice how I have here a fraction within a fraction. So I want to get rid of that by multiplying both the top and the bottom of this fraction by x plus 4. You can't just do that term by x plus 4. You have to do them all. So x plus 4 there, x plus 4 there, and you also have to do the denominator by x plus 4. And so that's going to give us the natural log of x plus 4 times x plus 4 times e to the x minus e to the x, right? Because x plus 4 times x plus 4 is a 1. All of that is over. I'll go ahead and put the x plus 4 here in the front. Natural log of x plus 4, then squared. Okay, so we're supposed to evaluate this at 4. So f prime at 4 is the natural log of 4 plus 4 times 4 plus 4 times e to the 4 minus e to the 4 over 4 plus 4 times the natural log of 4 plus 4 quantity squared. So that gives me the natural log of 8 times 8 e to the 4th minus e to the 4th over 8 natural log of 8 quantity squared. And I might do just a little bit of rearranging and put it 8 natural log of 8 e to the 4th minus e to the 4th over 8 times the natural log of 8 quantity squared. Again, we could find a decimal for this, but Hawks does not ask us to do that. But they do ask us to find the slope of the tangent at 4. Oh, we did that. Okay, so we're done. So g of x is negative 4 e to the 6x squared plus 8. We're supposed to find the slope of the tangent at x equals 2. So again, we need to find g prime of x first. And this one doesn't have a product rule because it only has the x in one place. But it does have a chain rule, because when you have e to a differentiable function, you have to take the derivative of that. And that's why I tacked on the 12x. So that's going to give me a negative 48x e to the 6x squared plus 8. And now we just want to plug in a 2. So g prime of 2 is negative 48 times 2 e to the 6 times 2 squared plus 8, negative 96 e. Let's see, we're going to follow our order of operations. So that's going to be 6 times 4 plus 8 is 24 plus 8. So e is going to be to the 32. So the slope of the tangent at 2 is negative 96 e to the 32. Example 7. Find the open intervals over which the function is increasing or decreasing. Now remember that a function is increasing when the first derivative is a positive. So that's when it's increasing. And then f double prime of x is first derivative at x less than 0, then the function is decreasing. Now remember how we do this. We find the derivative, we put the critical numbers and the discontinuities on a number line. Okay? Well, there are not going to be any discontinuities to an e function, because an exponential function, all of them look like this, or they can decrease, look like this. So this is a nice continuous. Remember we said the domain of the e function was negative infinity to positive infinity. It has no discontinuities. So all we have to do is put our critical numbers. So we have to find f prime of x and set it equal to 0. So it's going to be e to the negative 0.8x times negative 0.8. Oh, let's see. I wrote this function wrong. Let me fix this. I'm sorry. Y'all bear with me here just a minute. This plus 7 is in the exponent. So e to the negative 0.8x plus 7. So we're going to have to use the chain rule. 0.8x plus 7. You copy the e function, then take the derivative of that, which is negative 0.8. Okay? So we'll put the number in the front, negative 0.8 e to the negative 0.8x plus 7. Okay? Now, if we set this equal to 0, okay, there are going to be no solutions. So let me show you why. So we'll go about solving this. It may have been a while since you've done these, but I'll show you how. Using just regular old techniques. So we have an e, which is about 3, raised to an exponent, and we're never going to get 0. Now what you would normally do, if you want to solve this, is you would take the natural log of both sides, and here's where we know that there's going to be no solution. And that is because when we take the natural log of 0, that's a no-no. The natural log of 0, remember, the domain of the natural log and all logs is the arguments have to be bigger than 0. So they can't be 0. So our answer here is that there are no solutions. Okay, so we have our number line, and we have no critical numbers, but we still have to test. So remember, we're testing inside of the derivative, and this is our derivative, and that's an e, and we can pick anything to go in an e function because this domain is all real numbers, so I'm going to pick 0. Okay, so I'm going to evaluate f prime at 0. Now you can't put a 0 in a natural log, but you can put it in an e function. So that's e to the negative 0.8 times 0 plus 7. And wait a minute, that's not the actual derivative, that's negative 0.8 e to the negative 0.8 times 0 plus 7 is negative 0.8 e to the 7. So that's a negative number because remember, this is a negative, and e to the 7 is about 3 to the 7th power. That's a positive. So f prime of x is less than 0 because a negative times a positive is a negative. So this function is decreasing always. Remember, our number line was wide open. It's decreasing from negative infinity to positive infinity. Example 8. Find the open intervals over which the function is increasing or decreasing, where f of x is 7 times the square root of 7e to the negative 6x plus 4. Well, with all radical, and in this case square root functions, we use a fractional power, and a square root is always a 1/2 power. So this is just going to be a power rule. So 7 power base let's see, that's not in the exponent. Power minus 1. And now since this has a derivative, we have to do the chain rule. So that's going to be 7e negative 6x times the derivative of the exponent, which is negative 6. Okay, so we got a lot of cleanup to do here. 7 over 2, 7e to the negative 6x plus 4 to the negative 1/2 times all of this, negative 42e to the negative 6x. So let's get these monomials to the front. So I've got to do 7 over 2 times negative 42. That's going to be a negative 21. So that's going to be negative 147 e to the negative 6x times 7e to the negative 6x plus 4 to the negative 1/2. So that ends up being negative 147 e to the negative 6x over, now all of this has got a negative exponent, so it's going to the denominator, and I'm going to change it back to a square root of 7e to the negative 6x plus 4. So it's in the denominator because it's negative, and it's a square root because it's a 1/2. Now, they've asked us to find where it's increasing or decreasing. So the only place that a fraction can be equal to 0 is if the numerator is equal to 0. So we set our numerator equal to 0, but an e function is never going to be equal to 0. Okay? We saw that from the remember this last example where we set an e function equal to 0 and we came up with no solutions? That's true. It's going to be true for any e-based function. It's always going to come out positive. Try it on your calculator. E to tons of different things and see that you always get a positive number. That means I have an open number line. I'll pick anything that I can put into an e-base, but I can't allow my denominator to be 0 either. But look, this would never be 0 because this is a positive number plus a 4. So it's always going to be some positive number. So I can pick anything I want, so I'll pick 0. So we're going to do f prime of 0 and see if it's positive or negative. So it's negative 147 e to the negative 6 times 0 divided by the square root of 7e negative 6 times 0 plus 4. So that's going to be negative 147 e to the 0 over the square root of 7e to the 0 plus 4. Well, any base to the 0 is 1. So that's going to be negative 147 times 1 over the square root of 7 times 1 plus 4. That's negative 147 over the square root of 11. That's a negative number because it's a negative divided by a positive, which is a negative. Since it's less than 0, this function decreases from negative infinity to positive infinity, and it never increases. Okay? Now, be careful about overgeneralizing. All e-based functions do not decrease. Sometimes they increase. Remember, I said the graphs of e-based functions can look like this, or they can look like this. Hold on, not like that. Wait a minute. Like this. Okay? They could even look like this under here, or like, let's see, this, like this. So we don't know if they are rising or falling until we do the actual evaluation.